All right, so we continue in our study on linear graph. So the objectives that we have today, we want to learn how to calculate the midpoint of a line segment. We want to calculate the magnitude of a line segment, determine the perpendicular and parallel gradients of a line relative to another, and we want to calculate the equation of a line when 2 points are given. So from what we've been doing, we've been actually looking at the graph and calculating it based off of observation. So I gave you guys some to do for homework. We'll go through that, but first you can take on your objectives and we're going to use that as a refresher to what we did so far. All right, lovely. So the first thing now, line segment, right? So a line segment is a section of a line that has two distinct points. So if you look at this here is a line. Notice how we have an arrow going this way and an arrow going that way. Can anyone tell me what they think those arrows are trying to imply? So basically what they are trying to imply is that it goes on and on and on and on. Okay, it doesn't stop. All right, so this here is like to infinity and this part is to infinity as well. Now a line segment now kind of marks a beginning and an end. So if you notice this line here, look what we have here. This line here shows that it's continuously going to this way infinity and to that way to infinity. All right, but notice how we have the dots. So A is here, B is here. These 2 points indicate a line segment. So that is what we refer to as a line segment. Does that make sense? Yeah. All right, good. So I want y'all to take this down, and then after we will try to look at a graph for what we was doing for homework to roughly remember the process of obtaining the equation of a line. All right, so that's going to be our premise for this lesson. You got to be able to do that, and we're doing it now without having a graph. So we will refresh ourselves on what it is to do it when we have a graph. So take this down and then we go to that. All right, so we want to get the equation of this linear graph. What are the two important things we need? The gradient and the y-intercept. In this class, we're going to be able to try to find a y-intercept without having a graph. But because we have a graph, we can use the graph to determine what the y-intercept is. Okay, so based off of this graph, what is the y-intercept or the c value? 2. Excellent. So we know that the y-intercept is 2. Good. The next thing that we need to calculate is what? What do we need to calculate now? The gradient. So in order to calculate the gradient, we need 2 points. So the points I'm looking at, we have this point here. This is a good point. As you can see, they intersect very well here. So this is -1, +4. Okay, that's 1. I can also use this one. This intersects nice right here. So 0, 2. Another good one is this point, but you have to be careful. Remember, the x value comes first. So the x value here is 1 and the outside one is 0. So 1, 0. You also have this one here, which is 2, -2. They intersect nicely here. Okay. There are many different options that we have. But all we need to calculate this gradient are 2. And we could use any 2 points. We're going to get the same answer. So I'm going to choose this one here and this one here. Okay. So that is -1, 4. And 1, 0. So what I have to do is label these x1, y1, and then x2, y2. So the gradient formula is what? What's the gradient formula?
y2 take away y1 over x2 take away x1.
Excellent. x2 take away x1 right here. Okay, so we have y2 take away y1 over x2 take away x1. So I've already labeled these. This is why it's so important to label these. Because now that I have these labeled, I can say, oh, my y2 is actually 0. So I can say 0 minus y1, which is 4. And that goes over x2, which is 1, minus x1. Now, I'm going to minus here, but this is something I need y'all to be very careful with. Oftentimes, when you put in negative numbers, people forget to take away -1 and just leave it as 1. But remember, we have to do minus -1. Okay, that's very, very important. So do not forget that. So 0 take away 4 gives us -4. All right. And then 1 take away negative 1 turns into 1 plus 1, which is 2. So when I divide these two, I have negative 4 divided by 2, which is negative 2. So now I have my gradient. My gradient here is negative 2, and my y-intercept is c, which is 2. So my m, our gradient, is equal to negative 2. My y-intercept is equal to c. So I can write the equation of the line here, which is y is equal to m, which is negative 2. So negative 2x plus c, which is 2. So my equation is this. All right, does that make sense? Lovely. So today we're going to learn to figure out the y-intercept if we did not have this graph. So you'll see how we do that in a bit. But first, let's talk about the midpoint of a line segment. All right, so the midpoint of a line segment is halfway between 2 points on the line segment. All right, so by observation, how would you find the midpoint of this line? Where you think the midpoint would be?
I ain't got no length, so I can't find the midpoint.
Okay, so can you approximate it?
Move your cursor.
All right, so here is my midpoint, right? So how do you know that's the midpoint?
By eyeballing it.
By eyeballing. So if you're eyeballing, what were you looking for?
An even stretch between A and B. Okay, like wherever I put the point, it should be even on both sides.
All right, good. So let's just say this here was the midpoint of this one. Okay, now like you mentioned, let's put some numbers to it. So let's just say this m, instead of being m, this is actually 5, and instead of being n, this here is 7. The question is now, what do you think the midpoint would be?
6.
Y'all sure?
Yes. Yeah.
So how you know that's the midpoint?
Because you have 5 and 7, you guess.
All right, so mathematically, how did you calculate that?
1, 2, 3, 4, 5, 6, 7. Yeah.
I like that one. So what we could do is, we could also go like this: 5 plus 7, which is what? 12. And the midpoint would be what? 12 divided by 2, which is 6.
So you got two numbers or just divide by 2 in general?
Because 2 usually gives us the halfway mark. Divided by 2 is like finding the average between the two numbers. Okay? And the average between the two numbers would give you the center point.
Alright.
So you are correct in that sense as well too.
Okay then.
You see what I'm saying?
Yeah.
Yeah. All right, good. So we figured out how to do the midpoint just now, right? Now the thing is, when we have the midpoint of a line segment, is the same thing. It's just the middle between two given points. Okay. So we can identify that by calculating the coordinates. So obviously we would group the x's together and the y's together, and that would allow us to find a halfway mark on both sides. So both from the y-axis point of view as well as from the x-axis point of view. Therefore, our formula to get that would be this. So x1 plus x2, so whatever the coordinate is for here and the coordinate is for here, we will basically use those values, x1 plus x2 divided by 2, then y1 plus y2 divided by 2, and each of those would represent the x and y coordinates of the midpoint. So take this down and we'll go through examples so you guys could see and understand what we were just talking about. And make sure y'all write down your notes, okay? All right, so the reason I'm doing this is I want y'all to see visually the representation of what we're actually calculating, okay? So in order to find the midpoint of a line segment, notice this is where the line ends at A and B. So that is just the points that we have here to call that. So we can say A, the coordinates of A would be what? What's the coordinates of A?
Minus 2, 6.
Wonderful. And what about B?
4 minus 6.
4 minus 6. Good. So just like what we do when we are trying to calculate the gradient, we label these as well. So for instance, this would be x1. Here would be y1. This would be therefore what? x2. And this other one here would be what? y2. Good. So now that we have x1, y1, and x2, y2, we can use our formula for the midpoint. So the midpoint, the coordinates of the midpoint would easily be just x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. All right, so x1 is negative 2, so negative 2 plus x2, which is 4, and we divide that by 2. So that would be our x coordinate. Now our y coordinate would be y1, which is 6, plus y2, so 6 plus negative 6 over 2. So we're dividing that answer by 2. So negative 2 plus 4 is 2. So 2 over 2. And then we're going to have 6 plus negative 6, which is 0 over 2. All right. So now we can say now 2 divided by 2 is 1. And then we can say 0 divided by 2 is 0. So therefore, 1, 0 is considered to be our midpoint. All right, so 1, 0, which is here, is our midpoint. So notice when you compare here, you can see that the same distance from here to here is the same distance from here to here. So right here is our midpoint M. All right, so what we do here in calculation translate to a visual representation of what that is. So I had this here to show you guys what it actually looks like when you compare your answer to a real graphical representation of your calculation. So this is your first midpoint example. So I want you to take down this question using these points and write this down as your first example, then I'll give you one to try. Was that difficult?
Nah.
All right, lovely. So make sure when you're calculating this, make sure you write down your formula. After you write down your formula, make sure you pick the 2 points correctly. Make sure you go x first, then y. X first, then y. Then you label it x1, y1. Then x2, y2. Alright, so let's try this now. So this coordinate here is negative 1, 4. So here is negative 1, 4. Here is 2, negative 2. I always go with the x coordinate first, then the y. So we said that the midpoint, if we want to calculate the midpoint, in order to do this, what we will have is x1 plus x2 divided by 2. So that's our x coordinate. And then we're going to have y1 plus y2 over 2, and that's our y coordinate. So now that we have these 2 points, so negative 1, 4, and we also have 2, negative 2, I have to label these first. That's the first thing I need to do. So this one is going to be x1, y1. Then here is going to be x2, y2. So then I could say x1 plus x2 to get this part of the formula. So negative 1 plus 2 divided by 2, comma, and then I'm going to have y1, which is 4, plus negative 2 over 2. Now I can work this out. So negative 1 plus 2 is 1. And then I'm going to put that over 2, comma, 4 plus negative 2 is 2. So 2 over 2, and that's my coordinates. So I would simplify these. So this here is basically a half. And then 2 divided by 2 is 1. So when I look for my coordinate, half, 1, half on the x-axis is somewhere around here. So here is about half. And this half has to match with 1. So here is 1. So right here, as you can see, that's my midpoint. All right. So this here is what we do to calculate the midpoint. The graph that I have here is just to give y'all a visual representation of what that looks like. Okay. So does this make sense to y'all now? You guys understand?
Yeah.
Good. All right. So sometimes you get fractions, sometimes you get whole numbers. Okay. So don't let that worry you too much. Okay. So that's something to bear in mind. All right, so we want to look at the magnitude or the length of a line now. All right, so the length of a line, this is also referred to as the magnitude. The magnitude, right? So the length of a line uses a similar concept to what we did in trigonometry, which is Pythagoras' theorem to determine length. However, you don't have to work it out that way, but the formula itself uses this concept, okay? So another way of referring to the length of the line, a question could ask you to find the magnitude of the line. All right, it could ask you to find the magnitude of the line. So when you hear a question saying what's the magnitude of the line segment AB, it's just asking you for the length of the line. Now in order to do this, what we need is the formula. So what we need to learn for this is the formula, and this is the formula here. We're still using the same concepts from x1, x2, y1, y2, and so forth to be able to calculate it. But notice what happens here. This time it's saying x2 take away x1, and we find that difference, and then we square it. Then we do y2 minus y1. We find the difference, obviously, and then we square it. Once we do this, we find the square root of it. Okay? So this is a concept that basically comes from Pythagoras theorem to find the hypotenuse. Obviously, we don't have to go into the details of this formula, but essentially, this formula comes from that. If anyone is ever interested, I don't mind showing it to you. But for now, all you need to know is that this here is derived from Pythagoras theorem, and it calculates the length of that particular line. So what you can do now, you can look at this, write this down, make sure you have it there, and then we're going to try an example of it, and then y'all will try your own on it, and then after we go to the next segment of our lesson today. Alright, so we are trying to calculate the length of this line segment CS. So we have C here, which is negative 2, 3. As you can see, negative 2, 3. And S, which is 4, 5. 4, negative 5. Now, we are going to pretend that this graph is not here. So we are just using this here to be able to work this out. But I just want you to understand from this point of view what we're actually calculating here. All right. So when you look at this here, magnitude is the first word that I see popping up in my head. It's like, what is the magnitude? So we could say the magnitude is the same thing as finding the length. So we said that the length can be used or calculated using the equation square root of x2 minus x1, and then we square that, plus y2 minus y1, and we square that as well. So once we find this answer and we add them together, we square each of them individually, then add them together. Then after that, we find the square root and we have the length. So looking at this, I'm going to label this x1, y1. The same process. We're doing the same thing over and over, guys. Labeling it x2, y2, x1, y1, and all that stuff. It's the same process over and over. So now that I have that, I can put that into this equation, this formula here, by substituting it. So the first thing I have is x2. So x2 represents 4. So I can say 4 take away, and notice what I'm doing here, take away x1, which is negative 2. Notice I'm not shying away from putting back negative 2. So I'm going 4 take away negative 2. And then I'm adding now y2, which is 5 minus 5. So minus 5, subtract y1, which is 3. And then I'm going to square that answer. So I'm just breaking this down so you can see each and every step. So 4 take away negative 2. 4 take away negative 2. If we put that in the calculator, it's going to give us 6. All right, so 4 take away negative 2. So we want to square that answer. Then we're going to add now. So negative 5 take away 3 is the same thing as negative 8. So we're going to square that answer. Okay, so the square root of 6 squared. So what is 6 squared? What do we mean when we say 6 squared? 6 times 6, which is 36. And then we're going to add that to negative 8 squared. So negative 8 squared is the same as negative 8 times negative 8, which gives us 64. Remember, a negative times a negative is a positive. So 36 plus 64 would give us 100. Now, what's the square root of 100? Excellent. So the square root of 100 is 10. And since they didn't tell us whether it's in centimeters or meters, we're going to just say 10 units. So what we're saying is, if you look at this, these boxes go across like this, right? So we have 1, 2, 3, 4, 5, 6 boxes for this one. And then we go up 1, 2, 3, 4, 5, 6, 7, 8 boxes. So 6 boxes here, 8 boxes here. So what we're saying is from C to S, that represents 10 boxes. Okay? Now, you can always check it in your own time. But if this is 8 centimeters here, for instance, and this is 6 centimeters, if we do Pythagoras theorem, you would find out that the answer here is 10 centimeters. Okay, so essentially, we would get 10 units, in other words, right? So that is how it uses. It uses the Pythagoras theorem in this to basically work this out, okay? Because the difference between this here, x2 take away x1, is basically the distance between this negative 2, which is x1, to this distance 4 that we have here, which is 6 away from each other. All right, so that's why we end up with 6 squared here. All right, and then 8 here as well. Okay, the whole point is this formula basically gives us the length of the line segment. All right, so I want y'all to take down this example. Notice here how when we had this negative, I included that as well. You have to include that, otherwise it's gonna get you in problems with your final answer. The same thing with this one here, very intentional. Look, we have -8. It's important to know that -8 times -8 is 64. When you put this in your calculator, you have to put it in brackets. So open brackets, -8, close brackets, then you square it in your calculator. So then now once you get that positive number, you can add it to the 36, and then you'll get your final answers here. All right. So these usually the 2 points that tend to mess people up. So make sure you're careful with that. So take this down and I'll give you all one to try. By the way, when we do these kind of questions, we don't always get whole numbers. So in this case, we got whole numbers because I want you to see what it's like going through the process, okay, to make it a little easier to calculate. In reality, there are times that we could actually get decimals as well too. All right, so everybody got this? All right, so you guys try this. So try to calculate the magnitude of a line segment GP, where G is -3, 1, and P is 1, -2. So let's see how y'all work this out now. This is our formula that we use to calculate the length. X1, Y1, X2, Y2. So then now X2 would be represented by 1. So I'll have here 1 take away X1, which is -3 squared, plus Y2, which is -2 take away 1 squared. So X2, which is 1, take away -3, and then I have -2, Y2 take away 1, which is Y1. So then now I could say 1 take away -3. If you put that in your calculator, you'll end up with 4 squared. All right, plus, and this is the important part, -2 take away 1 is -3. Okay, now 4 squared is 16. I'm not concerned about 4 squared, that's easy stuff. What I'm concerned about is this -3. Now why am I concerned about this -3? Whenever you're doing a negative squared, you have to put the brackets in first. The bracket and then -3, close bracket, and then squared. Okay, so -3 squared would give me +9. So we have to put the brackets in so the computer or your calculator would know that you want to square -3, meaning -3 times -3. Okay, so that's how you have to put it in your calculator for it to understand. So that means that -3 squared is equal to 9. 16 plus 9 gives us 25, so square root 25. And the square root of 25 is 5, so therefore we have 5 units. Does that make sense? All right, lovely. So now we're going to talk about parallel and perpendicular gradients. So the first thing we want to talk about, parallel lines. So what do you know about parallel lines?
If they can't touch.
They don't touch because they are right, so they're the same distance apart throughout, right? Okay, good. So based on that premise, what do you think would be the gradient of two line segments that are parallel? So two line segments that are parallel, what do you think would happen to their gradient? Would it be the same? Would it be different? What do you think? Basically, they would be the same, because remember, if they're the same distance apart and they're traveling at that same distance and never actually touch, that means that they must have the same gradient in order for that to happen. The only thing that would be different is their y-intercepts. Right, so if you look at this, right, looking at this first equation here, so we have, for instance, y is equal to 3x plus 3, and then we have y is equal to 3x, then we have y is equal to 3x minus 5. What do you notice about all these three equations?
They all got 3 in it.
All right, they all have 3x, right? So when y is a subject, each of these have 3x because 3 represents the gradient. So if you look at this graph here now, we have 3x plus 3 here. We have y is equal to 3x here. We have y is equal to 3x minus 5 here. Now all three of these lines are parallel lines. And what we notice is their gradients are the same. Okay, so parallel line. So when we're talking about the gradients of parallel lines, we expect them to be the same. The next thing we look at is perpendicular lines. So before I tell you what perpendicular lines are, I'll just show you this diagram. Now, looking at this diagram, what is the gradient of the first equation? So the first equation we have is y is equal to negative 1 over 3x plus 5. What's the gradient of this equation?
Negative third.
Uh,
Minus a third, right?
minus a third. Remember, we don't include the x. Yes, so we just say minus a third or negative a third. All right. Now, looking at the next equation, 3x minus 1. So for this one here, what is the gradient?
3.
Lovely. So the gradient is 3, and we know this because of this 3 here from our equation y is equal to mx plus c. All right, remember this part represents a gradient. Now, we have two different numbers here. Notice when they are parallel, they have the same gradient. But when they are perpendicular to each other, notice that something's different. What do you notice? So one of the first things of notice is that the signs are different, which would make sense because once we form this 90-degree angle here, one line has to be going down while the other is going up. So what do we say about lines going up from left to right? Their gradient would be what? Negative or positive?
Positive.
Positive. And once they're going down left to right, we are saying that they are what?
Negative.
Negative. So then, that's one thing I noticed. They have a different sign. Now the next thing, what do you realize about these numbers? So I'm going to just say another way of writing 3 as a fraction. How can you write 3 as a fraction?
3 over 1.
3 over 1. So outside of the signs being different, what do you realize about these two gradients now?
They're like opposite.
In what way?
One has a negative, the other doesn't. And for one, the 1 is on top, the other and the 3 is on top.
All right. So we refer to that as them being reciprocals of each other. That's an excellent observation. All right. So I could basically say when lines are perpendicular to each other, we would expect that a gradient 1 would be the reciprocal of the original line and then basically multiply by negative 1. So in other words, that would mean that the original gradient is flipped and then we change the sign. So let's put that down. All right, so we say that a perpendicular gradient is a reciprocal of the original line and then we multiply that by 1. Okay, so let's just say here that m, or the gradient, was equal to negative 1/3. So if we was to flip 1 over 3, it would turn to 3 over 1. So let's say we had negative 3 over 1 because we flipped it. Then now we multiply by negative 1. So negative 1 as a fraction is negative 1 over 1. We essentially would end up with negative 3 times negative 1, which is positive 3. And then 1 times 1 is positive 1. So therefore, if we flip this and then multiply to negative 1, we get 3 over 1, which is the gradient that is perpendicular to this gradient. All right, so we'll do that in an example so you can understand. And essentially that's how you can work it out. All right, but if you're good at understanding that, hey, this is a negative number, all you need to do to find the perpendicular gradient is change this from being a negative number to a positive number and flipping it. Okay, so this number flipped would be 3 over 1, and then because it's negative here, I just make it positive down here. All right, so you guys take this down, and then after we'll do example of this, and I'll let you try your own, and then after we know that we got that segment down packed. So then the next step for us would be to basically do our last objective and do some examples of that, and then we'll try our activity where we bring in all of this stuff together. First one we have is y is equal to 4x minus 5. Now I want to know a gradient of a line parallel to this. So the gradient of a line parallel would equal to what? 4. Because once lines are parallel, their gradients are the same. So therefore my answer to this would be 4. Now I need to know for a gradient of a perpendicular line. So remember with this one now, you got two ways of looking at it. So I have to look at this previous gradient here. So the gradient of this equation itself is 4, which is the same thing as saying 4 over 1. All right. So what I need to do to work up the perpendicular gradient, I need to flip this 4 over 1 and change it to 1 over 4. And then I multiply it by negative 1 over 1. So 1 times negative 1 is negative 1. And then that goes over 4. So I know my perpendicular gradient is negative 1 over 4. Another way of doing it is, so this was one way. The next way of doing it is, I could just say, all right, we have 4 over 1 here. All I need to do is flip it, which is 1 over 4. And currently, this is a positive value. This here, as you can see, is positive. So since it's positive here, that means I need to make it negative in order for it to fit that criteria. And that's my answer for this. Okay, so there's two ways of doing it. This is a mathematical way. This here is by observation. All right, so let's try a next one. We'll try a next one. So let's say we had this one this time. Y is equal to negative 6 over 7x minus 10. So, based off of this question here, what is the gradient of this question? What's the gradient here? Minus 6 over 7. So that means the gradient of a parallel line to this would be what? Minus 6 over 7 because yes, once it is same, are they parallel, the gradient is going to be the same. Okay, so perpendicular line now. So what I have to do now, I can flip this. So flip this gradient because we have to find the reciprocal of it. So that's going to be, I could basically say 7 over minus 6, however you want to look at it, and then multiply that by negative 1 over 1. So essentially that's 7 times negative 1, which is negative 7 over negative 6 times 1, which is negative 6. So a negative divided by a negative is basically a positive. So that's going to be 7 over 6. All right, 7 over 6. Likewise, all we needed to do was flip this and then change the sign. So right now it's a negative number. So once I flip this, it's going to be a positive number. Okay, so then our answer would be 7 over 6. And that's it. So 2 for you to try on your own, and I want you to be able to identify both of them, okay, in that way. So I'll put them down for you, and then after you'll try to walk them down quickly. I'll give you 5 minutes to do both of these. With this one, parallel gradient, what would be the parallel gradient? 2, because once they're parallel, we expect their gradients to be the same. Now, perpendicular gradient. This would be negative 1 over 2. Now, remember, this is 2. So if we put it as a fraction 2 over 1, but to get the perpendicular gradient, we flip this. So it's going to turn to 1 over 2. And then we times it by negative 1 over 1, which basically gives us negative 1 over 2. All right, so you could have looked at it that way. Alternatively, you could have said, oh, 2 is the same thing as 2 over 1. Let me flip that, 1.5. So it's positive here, so that means I must make it negative to get a perpendicular gradient. So that's the processes that you could use to work that out. All right, so what's the parallel gradient for this one below here? 7 over 9. Excellent, 7 over 9. And the perpendicular gradient would be what? 9 over 7. Negative 9 over 7. All right, because we have a 7 over 9, we flip it, so that's going to be 9 over 7. And then we multiply by negative 1 over 1, which gives us negative 9 over 7. All right, so remember, perpendicular gradients have different sign and the numbers are flipped. Or other words, we have the reciprocal of those numbers. All right. So the last thing we're going to do now, we're going to try to figure out how can we calculate the y-intercept when we have only 2 points and we don't have a graph. But in order to do that, what I want to do first, I'll show you the graph and we will work out our calculations, but we'll pretend like the graph isn't there. So essentially we are just using the graph to get our information. All right, so that's going to be the last thing we look at, and then we do an activity to bring all of these together. So there's a reason why we are learning all of these in segments. So we are learning the midpoint, how to work out the midpoint. That's one thing. We are learning how to do the magnitude of a line segment, and then we want to determine the gradients, whether it's perpendicular or parallel. Now the next thing we're going to do is calculating the equation of a line when 2 points are given and we do not have a graph. Now once we learn that skill, the next time we have class, what we're going to be doing is basically trying to figure out the equation of a line that is perpendicular to another line and also a perpendicular bisector. Now a perpendicular bisector would be a perpendicular line that passes through the midpoint of another line. So in order to be able to do that, that's why we need to know all this information that we're doing now. So all these skills that we are working on right now, they're going to be coming together to help us work on something else. All right, so it's very important for us to understand these individually and then bring it all together as we advance. So just to give you an idea of what a perpendicular bisector would look like, so we have the midpoint here. A perpendicular bisector would be 90 degrees from this passing through. Okay, so that's what we're going to be looking at next time. So now I'm going back to how we started off this class. We started off this class with this question here. Now what we're going to do is we're going to use this diagram to basically help us determine the equation of the line, but we're going to use it with strict calculations. So we want to figure out what is the equation of the line segment AB, where A is -1/4, so this is A right here, and B is 3, -4. All right, so in order to do this question, we need to do it in stages. So I'm going to show you each stage and break it down in each stage for you. So the first stage that we need to do is understand what do we need to calculate. So we have y is equal to mx plus c. So in order to get the equation of a line, we need to have these two things. What are the two things that we need to have? The gradient and the y-intercept. So the first thing we want to look at is the gradient. All right, so the gradient, and we have 2 points, A and B, which would be -1, 4, and 3, -4. Now, this is me asking this question as if this graph was not here. All right, I'm just keeping it here for visual representation that we can reflect back and look at. So when we calculate the gradient, we say y2 minus y1 over x2 minus x1. So therefore, I need to label this one here. I would say x1, y1, x2, y2. All right, so y2 is basically 4, so I could say 4 take away, y2 is -4, so I could say -4 take away 4 over x2, which is 3, so 3 take away, and notice how I'm going to put back my -1, take away -1. Do not forget that. Okay, so -4 take away -4 is, -4 take away 4 is -8. And that's going to go over 3 take away -1, which basically turns to 4. So -8 divided by 4 is equal to -2. Now, I'm only dividing here when I get a whole number. If I was getting a fraction and I wouldn't get a whole number, I would just leave the fraction. Okay, so that's going to be important, as you can see, for when we try to find a perpendicular and all that kind of stuff. All right, so I know that my gradient is -2. In other words, m is equal to -2. So far, I have not done anything that we have not done before. Next thing I need to calculate is what? I have my gradient. What do I need to calculate now? The y-intercept. Now, what do we expect our y-intercept to be? 2. This is my y-intercept, but we are pretending that this is not here, okay? So if this is not here, how do we calculate it? All right, so we just found the gradient, and we have 2 coordinates given to us, which would be this and this. These are the 2 coordinates given to us. So what we do then, all we have to do is go like this now. So y-intercept, we have -1 and 4, so I'm going to try it with -1 and 4 first. So -1, 4. And I know that m is equal to -2. So looking at this, -1 represents what value? What value does -1 represent? What variable does -1 represent?
X.
So x is -1. And what does 4 represent? So y is equal to 4. Now, all right, so I'm going to split this in 2 because we're going to do this again for the next point just to prove that this can be done with the 2 points. So we're given a point, so we can use it. So now I just have to substitute it into this equation here. So y equal mx plus c. I can replace the y with 4. I'm replacing this m with -2. What am I going to replace the x with? -1. And then I have plus c. So notice what I did here. Y is basically 4, so I replace y with 4. M is basically -2, so I replace m with -2, multiplied by x, which is -1. The only thing I don't know is c. And that is why we leave c here like plus c, because we're trying to figure out what c is. So now I could say 4 is this, which is equal to -2 times -1. What's -2 times -1? +2, because a negative times a negative is a positive. So 2. plus c. So just looking at this question is basically telling us 2 plus another number c gives us 4. So what do you think that value would be? What do you think c is?
2.
Correct. 2. So just to represent this mathematically, since it's positive 2 here, we have to subtract it on the next side to get rid of it here. Positive here, negative over here. So then we'll have 4 take away 2, which is equal to c. So 4 take away 2 is basically 2, which is equal to c. All right. So I worked out my y-intercept. Now you may ask me, but teach, would it work if we use the other coordinate? Because we had 2 coordinates. We had A, which we used, and we also had B. So let's try it with B now. So B is 3, negative 4. The gradient is still equal to negative 2. In this case now, what is the value of x? 3. So what is the value of y? Minus 4. So we work the same concept. Y is equal to mx plus c. So we replace this y with negative 4, which is equal to m. M is negative 2, so we're going to multiply negative 2 by x, which is basically 3. And then we're going to add c. So if we work this out, it's going to be negative 4, which is equal to negative 2 times 3. So a negative times a positive is a negative, and 2 times 3 is 6 plus c. So then now, since it's negative here, that means once it's going over, it's going to turn to what? Plus 6 to keep it balanced. So then we're going to have negative 4 plus 6 is equal to c. Negative 4 plus 6 is equal to 2. So I just calculated the gradient as well as the y-intercept. All right. And that's if I don't have a graph. Okay. I just had this graph here to prove to you the point that once we look back at this, we would see that the y-intercept is indeed 2. Okay. So then I can actually write the equation of the line now because I have the 2 most important things, the gradient and the y-intercept. So therefore, the equation of the line is the last and final step once we have 2 of those together. So y is equal to mx plus c. I can replace the m now with my gradient, which is negative 2x, plus my y-intercept, which is 2. Okay, so you just realize from what we did here that it does not matter which point you use, you will get the y-intercept that you're looking for. All right, so I want you guys to take this down, this example down, and then after we work on an exercise together. Okay, well, I'll let you guys work on it and we'll go through it together. So basically this exercise will allow you to practice everything that we did just now. Now notice in these questions we have to calculate a y-intercept. Just like what we did just now, this is the stage that we had. We had to calculate a gradient, then the y-intercept, and then the equation of the line. So we are basically encompassing all the basic skills that we needed in order to complete today's class. And then we'll take these skills and transfer them to our next lesson.